All right. Hello everyone and welcome back to my class. Now, since we introduced and we talked a lot about scientific form in the previous video, we learned how to write any number in scientific notation. Let's check one example quickly before we proceed with today's lesson. So if we have, for example, 56,000, in order to write this in scientific notation, we said we need a number that is between 1 and 10, and then we multiply that by 10 to the power of something. So we count how many times do we move the point to reach a number that is between 5 and 10. 1, 2, 3, 4. We move the point 4 times so that we reached 5.6. And you basically have 5.6 multiplied by 10 to the power of 4. Excellent. Let's have one more example. If we have, let's say, 0.0052, we need, again, a number that is between 1 and 10 multiplied by 10 to the power of something. We learned that if a number starts with 0, we move the point this time to the right side. How many times? 1, 2, 3 times. But because the number starts with 0, it is less than 1, so our exponent is negative. Okay, what is the number that we have once we put the point here? 5.2. But more about scientific notation and how to write any number in scientific notation, or the other way to say that is in standard form, you can find in the previous video on my YouTube channel. So make sure that you check that before if you need any help with writing numbers in scientific form. All right, if that is clear, let us move on. Make sure that you check later on description box where you can find lots of questions, lots of practice questions together with answer keys for you to solve it by yourself and to actually check your knowledge. Now, we say adding and subtracting numbers in scientific notation. If we have, for example, 4.5 multiplied by 10 to the power of 3, we add this to 1.2 multiplied by 10 to the power of 3 as well. All right. The most important thing when we add or subtract two numbers in scientific form is we must have same exponents. So our first number is 10 to the power of 3. The second number is also 10 to the power of 3. Then the only thing that we do is add this one by this one and copy your exponent. So it will be basically 4.5 plus 1.2, 4.5 and 1.2, we get 5.7. The answer will be 5.7. And then since they have the same exponent, we copy that exponent and leave it as it is. That's it. That's all we need to know if adding, subtracting two numbers in scientific form if they have the same exponent. All right. Now, what's the logic behind this? Same as if you have, for example, 3x and you have 5 more x's. What's the answer to this question? 3x here and 5 more here. The answer will be 8x. That is why we add this number and we just copy 10 to the power of 3. Good. Let's do one example with subtraction. So if this makes sense. If we have, for example, 4.11 multiplied by 10 to the power of minus 2 this time, minus, let's say, 1.5 multiplied by 10 to the power of minus 2. All right. The first thing that we have to check is, do my numbers have the same exponent? 10 to the power of negative 2, 10 to the power of negative 2. Yes, they do have same exponents. Perfect. The only thing we need to do is subtract 4.11 minus 1.5. All right, let's minus it here. 4.11 minus 1.50 will be 1 minus 0, 1. 1 minus 5 doesn't work, so 11 minus 5, 6. And 3 minus 2 is 3 minus 1 is 2. So we basically have 2.61 multiplied by, let me just make it smaller, multiplied by 10 to the power of, we said we copy the exponent, 10 to the power of negative 2. That's it. That's how you do it. So if we have same exponent, everything is super easy. What if we have this example over here? Let's say 4.8 times 10 to the power of whatever, let's say 5. We add this to 7.3, let's say, multiplied by 10 to the power of 5. All right. Do we have same exponents? Yep. Then it's good. Then it must be easy, right? What we do, we add the numbers. 4.8 plus 7.3, that will be 11, 12. That will be 12.1. Multiply that by 10 to the power of 5. Good. This is correct. But we have to make sure that our answer is also in scientific form. Is it? Do we see any problem over here? Oh yeah, we do. We learned that in order for a number to be in scientific form, we need this number to be between 1 and 10. It is not between 1 and 10. So again, in our previous lesson, we learned that this point has to be moved to the right. So we add 1 to our exponent, which basically becomes 1.21 and then 10 to the power of 6. Now we have it. It is correct. So if they have the same exponent, we add the numbers. We added 4.8 and 7.3. We got 12.1. But 12.1 is not in scientific notation, so we wrote it as 1.21. But then our exponent, we have to raise it to 6. Excellent job, excellent job. Now let's try something else. If we have, for example, 5.2 times 10 to the power of 4, we need to add this to 8.2, let's say, times 10 to the power of 5. We have a problem here. What is the problem? We said step 1 is check if they have the same base. Do they have the same base? No, they don't. Then you have to do something so that your numbers have the same base. What do we mean by that? We need for a moment to write one of the numbers so that it's not in scientific form anymore. For example, you decide whether you want to fix the first one or the second one. Let's try to fix the second one this time. 10 to the power of 5. I want it to be 10 to the power of 4 so that it's the same as this one, right? But in order my final answer to be 10 to the power of 5, in order for that to remain unchanged, we have another 10 to the power of 1. So 10 to the power of 1 and 10 to the power of 4 will give me in the end 10 to the power of 5. Nothing changed. Then we copy 8.2. 8.2 multiply by that. Perfect. What we need to do is, what is 8.2 multiplied by 10? That is 82. Excellent. 82 multiplied by 10 to the power of 4. Perfect. We copy the first number again. 5.2 multiplied by 10 to the power of 4. Oh, then it's easy again. Now this is something that we already know, right? It's 10 to the power of 4 and 10 to the power of 4. They have the same base, which is perfect. What we need to do is add the numbers. 5.2 plus 82 will be equal to 87.5. We copy the exponent, 10 to the power of 4. Oh, but we have one last problem, one last step here. We need to fix this, to write 87.5 in scientific notation. So we all remember it by now. It's going to be 8.75, but then we raise the power to 5 again. That's it. This is the final answer. So basically, in order to add two numbers in scientific notation, we need the same exponent. What we tried is, instead of 10 to the power of 5, make it 10 and 10 to the power of 4. Because in the end, that's 10 to the power of 5. 8.2 multiplied by 10 is 82. Aha! Now this one is to the power of 4 and this one is to the power of 4. Perfect! Add the numbers to get 87.5. Copy the exponent. Now that we have it, one last thing to be fixed. Write it again in scientific notation. Now I told you there is another way to do this. Let me copy the numbers again. 5.2 multiplied by 10 to the power of 4 and 8.2 multiplied by 10 to the power of 5. What you can do is, you can make the first one 10 to the power of 5. But in order to make it 10 to the power of 5, there has to be 10 to the power of minus 1, right? Because minus 1 and 5 will give me 4. Alright, then we combine 5.2 multiplied by 10 to the power of minus 1, which means basically divided by 10, it becomes 0.52 multiplied by 10 to the power of 5. On the other side, we have 8.2 multiplied by 10 to the power of 5. Oh, perfect. Do we have the same base? Yes. Then we have no problems. The only thing we need to do is we copy the base, 10 to the power of 5, and we add the numbers. 0.52 plus 8.2. That is equal to 8.75. Now we have the same answer as we had before. So guys, in order to add two numbers or to subtract two numbers that are in scientific form, if they have the same base, we practiced it, it is super easy. If they do not have the same base, then you have to do something to fix either the first one here or the second one here, so that they have the same base and then we just add them or subtract them. Make sure that you write the comments if you have any questions so that I can explain it better. Check the description box, find the papers for you to practice, and see you next time. Our next lesson is multiplying and dividing numbers in scientific notation. And with that, we will complete all questions in this topic.